All right. So first off, I'm going to be talking about the indexer as it's a fairly important piece in the project.
So what does
Originally,
the
why
index
we
to do? What does that do, Voltec? The indexer.
Yep. So that's originally when we were first planning what the indexer would exactly do. We were looking at we've had a lot of issues with onboarding. It's not easy to really get a Hive account, and it hasn't been easy to get a Hive account for many, many, many years now. And we were originally asking for light accounts, and we've never happened. So we decided to make our own. And during that process, we ended up finding out that we could actually not only make an indexer that allows us to do the off-chain content, but also we could hook into other chains so we can use the identities from those specific chains. So that means you could log in with your Ethereum, your Tezos wallet. You could even theoretically do Bitcoin, although there's the support for actually doing signatures and whatnot in the browser isn't really there. So that's not very practical compared to like Ethereum or other chains that do have that way to sign stuff in the browser. So we decided to use a let's see here. We decided to use a technology called Ceramic. It allows us to do the identity side of it, the like logging in with your Ethereum, logging in with Tezos, logging in with different off-chain accounts. You could also do it without the blockchain. So if you want to just have a Ceramic account without any kind of like blockchain attached to it, you're not using that identity, you can certainly do that. It also gives us the ability to actually modify content in a distributed way. So in a sense, it's very similar to IPFS conceptually, where you have different nodes that are out on the network that you can download content from. You can pin that content and store it and then send it to other nodes. But it really tackles the mutable part of it. You can't really modify any content on IPFS. It's immutable. It's not permanent since nodes can unpin it and remove it from the network if they so choose. But it is immutable. You cannot change it. However, Ceramic is, but Ceramic uses IPFS at its core, so all of that data is effectively on IPFS, and the same concepts apply. But it has that actual upper level mutability that you can actually use, and of course, it's still signed and it's still secure. It's impossible to actually fake content. So someone can't modify your content if you upload it without your permission. It's the same sort of deal as really any other public-private key type system.
So let me just get an understanding from you who this affects, right? Because this doesn't just affect the individual users. This also affects the platforms in that the platforms can take this technology as a package and implement it, right?
Mm-hmm. Yep. So what would happen is a platform would they would set up their indexer. They would define a few different parameters of what they want to what they want to operate on their indexer. So if they don't want any content from other sources, so like ThreeSpeak or Dbuzz or other places, they can choose to filter that out so they don't index that content. If they want to, they would be able to just do only their content. So if they want to filter that out, the same with other platforms. If they don't want to see other people's content, they can certainly do that. But there's also some so there's the actual indexer side, that is the off-chain indexer, and then there's also the union indexer. And the union indexer is a mix between the off-chain indexer and then the on-chain indexer. So this actually re-indexes Hive posts and put that into a database, and then combines that with your off-chain posts. So for that, they would define some different rules of what they're actually looking for. Are they looking for just some general peak D posts, or are they looking for something more specific? And so they would write a very small amount of blockchain parsing logic to convert those posts that they have on chain into something that's a little bit more consumable for their application. In the case of ThreeSpeak, we would take those videos and parse out the IPFS hash from them, or the centralized URL for those videos. And then we put that into a database, and then we'd be able to redisplay that on the ThreeSpeak site. Now we're currently not using the indexer on the main 3Speak site due to the complexity of doing that migration is fairly large, and we're still working on the indexer. So that'll come out in the next couple of months, and we'll actually do that transition. However, we are working with Dbuzz on getting that integration happening very soon, and we've made a lot of progress the last week. So it'll be something where I can reasonably say another few days to a week that we'll have a live integration with Dbuzz. They'll have a
I
presentation
noticed
later on about that they can go
they,
in.
they are coming in later on, yeah?
Yep.
Okay, cool.
Okay. So I'm going to show a little bit more on the indexer side of things. I'm going to show the GraphQL, the read-only GraphQL endpoint. So we have two different APIs for the indexer. We have the read-only GraphQL, and then we have the REST API that actually is for the posting of content. You're going to also to be talking to a Ceramic API to actually post the content on the network, but then you'll send another request to the REST API to actually pick up that content and index it. Okay, so I'm going to show the public feeds first, and I'll talk a bit more about the pub sub peers here. So in this case, I have my public feed. I'm looking for some posts that don't have a parent ID. So the parent ID is like which post am I replying to a post, or am I just creating a root post on my blog? So I'm looking for that specific set of criteria. I'm looking for a creator ID. So in this case, this is my DID, which is a decentralized identity. And then I have some different fields that I can select from. So the stream ID, which is the unique ID that's on Ceramic, parent ID, which is in this case null, and then body, your body section of your post, title. I also have some author details about this. So if you're using the public feed without the creator ID, you can select what authors those. You can select the different fields of that author. So in this case, I have the description set, and then I just have my did there. Let's see here. So there's a few other fields here that you can use in your application. Category. So this would be similar to having a tag on your post. So this would be your primary tag of your post. Language. Pretty self-explanatory. The type of post. So in this case, for 3Speak, it would be 3Speak/video or something similar. The app would also be the name of the application /version ID. And then you also have some other fields. So for the JSON metadata, so that would be very similar to what you have currently in Hive Post. And then some more app-specific metadata. I'm not sure if that's going to change or not, or if they'll be combined. I don't know, but it's up to developers to select what they want to use.
So this basically allows for a platform to specify specific criteria related to the content that they want to present to their front end, and they don't need to have a set of individual content creators posting to their platform. They can just go into the Speak network and pull that data from there, whether it's been posted to Hive or via Ceramic account or through MetaMask. There's different criteria that you can set here to go pull specific content to your front end and display to your user base, basically, if I'm correct.
Yeah. So it's all off chain, which does add a lot of extra complexity in terms of the preventing spam. People can post as much data as they want onto the network, but platforms can choose whether they actually want to store that data or not, and it can easily be removed since it's not permanent. You don't need to parse through hundreds or thousands of gigabytes of blockchain data. You only need to parse through a very specific set. And we also employ Bloom filters and a few other peer-to-peer technologies that allows us to actually do the sync in a pretty efficient way, which we'll talk a bit more on in a second. So the community ref, this would just be a link to a community on Ceramic. So that would just be a Ceramic document that has your community details and a few other things. And finally, we have the children, the children field. This is actually this is all of the comments under my post. It could be other things like upvotes and downvotes and other types of operations that are relevant to this specific piece of data. It could be views as well. The problem with upvotes and downvotes is those have to be unique, and that adds a bit more complexity because you have different nodes that might have a certain upvote from a user, and then there might be another upvote on another node, and then there could be some conflicts there. That's something that I have to do more research on. But primarily, it's going to be for comments. The exchange, how this actually works is a bit complicated, since you don't have a central index that actually stores all the comments on Hive. All of the comments are on chain. On the Speak network, they are spreaded between different nodes. So actually finding and locating those comments, you have to go out and talk to different nodes and exchange Bloom filters and actually get the list of comments and then reprocess those comments for the front end. The good thing is the performance is pretty good, and the discoverability of other nodes works pretty well, so there isn't really too much issue there. And of course, if you have a bunch of spam from a user, you can just outright remove that content from your node if you so choose to. Of course, that being said, your content can be stored on many, many different nodes. So if there is if there is some front end that doesn't want to display your content, they can do that, but there's many other nodes that you can choose from and store their content. And ultimately, it's also stored on Ceramic, so that you have another layer of redundancy aside from the actual indexer, which stores it in a typical database. There's also the actual data that's on Ceramic and also on IPFS. And on that front of censorship resistant, you can also in the future, run your own Ceramic node on the local desktop, so you have everything of your account stored locally on your local daemon. All right.
Which means essentially, if the rest of the network gets shut down or some parts of the network get shut down that you rely on, you can fall back to running it locally on your computer and not have to worry about those other parts, right?
Yep, and it's a lot easier to operate the nodes. So I expect more nodes operating than, assuming there's enough support from the community, more full nodes operating than there would be on like witnesses. I mean, it'll take time until everyone sets up their nodes, but it's very practical to be able to run many different nodes without a lot of cost. I could easily see each node only costing $20 versus hundreds or thousands of dollars to get the very high-end hardware that it takes to currently run Hive nodes. So it's a different model, of course, but it will lead to higher scalability long term, and that's really what we want to achieve. Along with, of course, giving us the ability for people to log in from other places and being able to faster onboarding, etc. Okay. So I'll do a live demo for you of creating a post. Now, this is very basic: title, body, the description. Not very basic. Later on, when we have the dbus integration complete, we'll be able to show that. So I'm going to say test post. Birthday. All right. So I'm going to post this. Post. It might take a second.
It's got to be one of the best quality posts you've done for a while, Phil.
Yep. And then I got the yeah. I don't know. I mean, if someone wants to write me a post, drop it in the chat. So anyway, I'm going to go to the post here, and then now I have test post for Hive birthday. This is one I made earlier.
Nice.
Test that this is all working. Then I have some other hello worlds, and if you go here.
So just for people's clarification, this is off chain, right? This is not on the Hive chain. This is off chain with an off chain account. Is that correct?
Yep. All off chain.
Clear.
So here, there's an API request that goes to Hive because I want to get. I'm using Hive as an identity source here at Vault-Tec, and then that resolves to a DID. And then this actually goes in and fetches the GraphQL API that then gives me my list of posts here and all the data behind it. All right.
So the idea is that other platforms will also be able to integrate this indexer that pulls those posts to the front end, and they're off-chain posts that people can post to the platforms without having a Hive account. And then we can eventually, filter people across to upgrading to Hive accounts later.
Mm-hmm. All right. If there's any other questions, I can answer them mid through the presentation or at the end on this front. All right. So I'm going to talk a tiny bit about Half, as there's been numerous comments about why use Half. There's systems already available. And to my knowledge, they're drastically different systems. Half does give you the ability to parse through the chain and give you a very specific set of data that's specific to your application. But it still requires you to have a Hive account. It still requires operating a node and pulling down a lot of content. And it's certainly good for stuff that's that's all on chain, but for platforms that are just wanting to come on and might have their own custom logic, it's it still weighs them down a fair bit. But I do think that it's very useful for certain applications. But in the case of what we're targeting, it's not the best use case.
Yeah, we see it as a complement. We see the two working side by side, for sure.
All right. So I'm gonna go into the indexer, or sorry, not the indexer, the video encoder. So we're working on some software that is it allows you to operate in a video encoder node in ideally a very quick period of time. The setup process would be easy and straightforward, and then you would be able to encode videos from different platforms and earn rewards from those platforms. So what we've done is platforms would operate a kind of tasking node that handles tasks, the delegation of tasks to different encoder nodes on the network. And then the actual nodes on the network are just clients to those tasking servers. So those local clients will hook into those tasking servers, ask for some jobs. They would give up their identity to the different tasking servers, like their Hive account, their peer ID, their different details that allows them to actually send those payments from those platforms to send payments to those nodes. We currently have this operating with 3Speak right now, and there's still bugs with it, but we're working those out, and it is a lot better experience than what we had previously, as there's many issues with the previous encoder system that are now completely removed. So this allows us to easily run multiple nodes and run it with failover. So if a node goes down, and the tasking server detects that node goes down, that video will then get reallocated to another node, and that will get encoded. All of this is using IPFS. The encoder nodes run IPFS. The tasking servers run IPFS. You take in an IPFS hash. That IPFS hash is uploaded somewhere. The platform uploads it to their servers, or it's uploaded to some other place. And then the actual encoder nodes will then download that data and then encode it locally, and then re-upload that data to IPFS, and then it gets stored somewhere. And so far, this has actually been working very well. I was a little bit concerned initially about IPFS having discovery issues and some other problems with that, but it appears to not be an issue with our specific setups. But there's certainly a lot of things that we can do on that front to actually improve IPFS resolution and performance but we haven't really ran into that issue at all. So we've encoded well over 500 production videos, actual users on the site. Give or take a little bit, because I was just estimating, but we have quite a bit of videos that are being encoded or have been encoded in total. We currently, the main nodes are operated by me and Sagar, who's in the call right now. Let's see. The main pain points that we've had with the encoder has actually been more of the storage side, and the upload process from getting from the user to our servers, and then a bit of this actual management of that storage. So we are currently running IPFS cluster. An IPFS cluster allows us to easily handle pins across multiple nodes. So if one node goes down, then the other nodes will pick up and store that data. And so there's plenty of redundancy there. Right now, we're also doing the incentivization via beneficiaries. This will eventually be direct payments, where just a platform will send a direct payment to a encoder node. But right now, the easiest and actually probably best solution would be to just send them a small percentage of beneficiaries of the encoded videos. So if someone encodes a video, they get maybe 1% or 0.5% of that video rewards. So if they do a good job, we can scale it so it's 1% versus 0.5%. And what we've actually done is decrease the amount of percentage that we take on videos from our typical 11% to 10%, and then give the other remaining percent to the encoder. So that way we distribute more money to actual community running infrastructure, rather than us operating the infrastructure and taking the rewards from that. Also want to go through one thing here that I forgot to show now that I think about it. On the indexer node here, we actually do have a pub sub peer connected, operated by Brishtit Veha in the call. He's been a great community member that I've talked to him numerous times about the indexer. And as more and more indexers come online, we can see we can see more peers being discovered and connected to. All right.
So just for people who aren't as technically capable as Vaultek, basically what he's been saying over the last couple of minutes is that any user in the network can run their own encoder to help other users in the network encode their own videos, and you can earn from that. And basically, Vaultek's been demonstrating the tech that he's built behind that, and it's up and coming. It's we've basically got it all running, and we're testing it. When do you think, Vaultek, we're going to be ready to roll that out to the ecosystem so that other people can earn from encoding other people's videos?
I'd probably do it in groups. So I'd say we have the 2 nodes right now, and then we can start adding more nodes. I'll probably run a few more nodes of myself, although I don't really have a lot of hardware to put behind that aside from my one server. I want to make sure that the software is stable first, as when it has problems, it really does affect the site in a bad way. So it's definitely iffy because it is a production system, and I don't want to mess it up and cause people to complain, since there are a lot of people currently using it. Well, relatively, of course, we have about 70 people using the new encoder right now, and we're going to rapidly expand that out as we get our storage infrastructure up and running and add more nodes. So it's definitely a concern that if something does go wrong, then it'll impact users pretty quickly. So yeah, we'll open it up in small groups where we add 10 nodes and then 20 nodes and so on. And really, there's going to be no restriction or anything like that. We're not going to do something super exclusive, but please try to keep it. Don't try to run a bunch of nodes because that wouldn't be great if something goes wrong. All right, so I'm bit of the process here. We have a node operating, and just give some basic debug of starting up the different endpoints here. We have what the screen actually looks like on 3Speak. So in this case, there are 2 videos here. We have a video that's actually encoding that shows 1% encoded so far, and then we have another video that's still in the queue. So there's now some queue progress and other details that show the actual progress of when it will complete. With also one other thing is there is resumable uploads for the IPFS encoder. So if you have issues with your internet going down and having to re-upload, definitely let us know so we can get you on the beta list, and then you can upload using the resumable uploads. So if your internet goes down, it'll resume from where you last left off. Okay, and then here.
Yeah, just to add to that, Vaultek, this is a problem that we've had a lot, over time, where effectively people have been encoding their video using our software. And if their internet connection drops, then the system's not been great at telling them that their video encoder has stopped encoding. And it's been a bit of a stickler for us because we get quite a few complaints saying, "Hey, why is my video not encoding?" It's normally because that person's internet connection has dropped for a significant period of time, such that the connection's lost and the video can't find out where it was and can't continue encoding. So with what Vaultek's building here, and slowly but surely over time, we'll be able to get people near to you or yourself to actually encode those videos on your own machines, or have people who are near to you with more stable connections encode videos for you, rather than relying on our software. So it should make the encoding experience more decentralized, B, give the people doing that encoding the ability.
Hello?
Yep. Please keep going.
Yeah. Yeah. So it's up to not necessarily the encoding process, but if the
Vaultek,
connection does break, it can cut out the encoding process, even though the upload has gone through. Can you hear me all right? I'm just making sure.
Yeah, I can hear you.
Yeah, it was got a little bit broken up there, but I think your stream's caught up with mine now.
Okay. Yeah, so I have a bit of debug log from my server. Here's a nice JSON blob of the progress. So there's a few different stages here that represent the different resolutions. So 480p, 720p, 1080p. The percentage of that particular stage, and then the total percentage. Up above is a ceramic ID. I was initially wanting to do each encoder job is a document on ceramic that gets updated with the progress. So users would get that ceramic document, and then they would actually store that ceramic document on their profile somewhere. So in their profile data, they would have a set of encoding jobs. So that way they can go talk to multiple encoding services and get jobs from those, or like ask for jobs from those different encoding services, and then actually store those job IDs in their profile, so that if you log in, you don't need to hit up any specific API endpoint to get the list of your encoded videos, and you have all of it agnostic to the different services you actually use. So you can go from one service to another without any reliance on them. You have all of that data stored in a decentralized manner. All right. So on our end,
Super cool.
we don't on the Speak Network end, we don't have any of the storage nodes. Something that we're going to be working on. There's a fair bit of reliance on the actual token system to happen, since ideally we would want to incentivize that as much as we can. So right now we are just operating all of our IPFS infrastructure. As I previously said, we are using IPFS cluster for the storage of a lot of our data. However, that mainly applies to the new IPFS videos. However, all of our current videos, all of the thumbnails of those videos go on IPFS, which has actually been proven to be more reliable than the previous centralized image store. So that's good. Let's see. So yeah, our costs in storage are pretty high on the centralized S3, which we hope to get down quite a bit by storing more videos on IPFS, as the infrastructure is a bit cheaper by about 10 to 20%. We currently have a server with a little over 30 terabytes of data available, and we've only used a small amount of that because we are just rolling out the IPFS encoder. We are likely going to set up another server to keep storing that data in a redundant fashion. It should last us about 2 to 3 years or so. It really depends on how much gets put onto the network. The new encoder is a bit more efficient than the old encoder. There was some extra resolutions and things that weren't really necessary, so that's been improved. So hopefully it'll be a bit less than what we're currently adding on. So they'll help decrease our costs and ideally the cost of other people on the network, so it's more efficient. Okay. Next part is the CDN daemon. So one of the big issues that we've ran into with IPFS is slow loading times. Part of that being that the content is not cached, but there's also another part that is the indexing of the DHT. And we found that once you actually do connect to a node, and we've demonstrated this with the desktop app, the actual playback of a video that's stored from that node is pretty quick. And so with the desktop app in particular, users would encode locally, they would upload, and then they could play it from the front end. Well, they could play it from the desktop app and then also from like PeakD. And initially, when we didn't have any kind of manual connections to our nodes, it would be pretty slow. In fact, and sometimes it wouldn't actually work at all. But once you actually have established a connection with a IPFS gateway, the playback does have some problems. But if the internet connection of the user is fast, then it will actually operate pretty well. That being said, of course, it's somewhat dependent on the actual performance of that node that they're operating, that user connection. IPFS is getting faster on the actual exchange, and recent versions have been significantly faster than when we actually build a desktop app, so that might have changed. So the CDN nodes allows us to actually run an IPFS daemon in a very easy, quick setup, along with some extra caching on top of it, and then actually doing the DHT index. So going out and indexing the DHT and putting in a database so that the actual resolution times of those connections are under a second versus 10, 20 seconds to actually find who is storing what. And in some cases, never responds at all. Never actually finds any peers that are storing the content for just reasons of inefficiency of the IPFS DHT. So ideally what we would be doing for the CDN daemons in terms of the incentivization is someone would set up their node, they would enter in their Hive credentials, they would, or well, they'd enter in their Hive name at the very least. They'd then post some kind of operation either to the other indexing system, or the our RF chain indexing system, or the actual Hive chain. So then there will be an index of all of those different nodes operating. So then people can decide, platforms can decide what nodes they want to choose from, and request CIDs to be stored and cached. So that would be sending them 1, 2 Hive maybe, and then those nodes would actually go out and store that content. There will be two kind of tiers. They'll be actually storing that content, so having that stored locally on the CDN daemon. And then the other one would be doing the DHT index. Those have different costs. If you're storing, there's a lot more cost, versus the DHT index, you just need some processing time and network usage to then go out and talk to different nodes and index. And then if that data is requested, then that resolution is pretty quick, but there's quite different costs in that. But it still is work that you have to do. So if end users, whether that be the platforms or actual users, don't want a ton of costs, they can just do the DHT index, and then that will get indexed in the background. We made the setup pretty quick and easy. You just run one simple command on your server, and it goes ahead and sets up SSL, IPFS, a bit of extra caching on top of the IPFS daemon, and then the actual DHT indexing software, which goes out, talks to IPFS, and then actually indexes those CIDs. We've also built a very simple domain solution for easy setup. One of the issues that we ran into is every individual operating these nodes would need to bring their own domain. So that means going out to Namecheap and buying a domain and then setting it up manually. And that makes the setup a lot slower and more complicated, especially for non-tech savvy users. So we've built a very simple system that allows nodes to go out and register speak.domains. And they would get this randomly generated URL here. And so that would set up domain, set up the SSL for that domain, and then you can actually go to that domain and view IPFS content from there. So in this case, this is my production domain that I'm operating. This actually powers the 3Speak website right now, and it's been doing pretty well considering it's on a fairly low end server, and there is some, of course, extra caching on it. So that's been powering the 3Speak site for a few months now.
So Vaultek, can I just jump in here real quick, just to give people a little breather, because there's a few people that can't quite follow all this, because obviously it's very tech heavy. Yeah. So just while you regather, I'll just quickly say to people, the CDN is content delivery, which effectively, especially for video, you need, because if you want to have a high quality video delivered and you're trying to stream a video that's stored on the other side of the world, say from like South America, it's stored over there, and you want to watch it in the UK, it's going to be a very, very poor quality stream. So what a CDN really does, and I might not be technically perfect on this, but in terms of the way I see it, is you have a guy that's local in the UK. He sees that there's a demand in the UK to watch that video that's stored in Argentina or whatever, and he goes and takes a copy of that, puts it onto his server, and then he can distribute that locally to a lot more people, and the quality is a lot higher. And then he takes on the costs of that stream, basically. And then what we're trying to do with the Speak network is allow people to run those nodes individually, because of course 3Speak, the platform, in terms of our team, we pay and run one of those on our own, and it's very, very expensive, and it's centralized in sort of general terms. Whereas when we give these nodes out to the community to run and earn money for running them, and earn Speak governance token for running them, hopefully eventually, then you're effectively decentralizing the capability of the network to serve high quality video to the local people that are near to the nodes that you're operating. So just decentralizes, again, it decentralizes the infrastructure. It allows people to run this infrastructure peer to peer without relying on us, without relying on any other party. And it allows for the quality of videos being viewed by the people to be very, very high compared to what they would be if you were just relying only on IPFS, for example. I think people may have caught up a little bit there, but let's continue then, Vaultek.
Yeah. Yeah, if you interrupt if you want to help explain, as I am very much covering the technical aspects, and I'll translate a little bit.
No worries.
So yep, I have a bandwidth graph here. There was a lot more usage previously, but we did some shifts in the way we're doing things, so it's a bit less now. But that'll grow as we add more and more content to IPFS. Okay, let's see. So we have the desktop app, which has been around for a lot longer than the rest of the project. So it's a full-fledged desktop app. You can download it. It has a rough version of our front end running locally. It operates a IPFS node automatically, so you run the desktop app, and it'll start up an IPFS daemon. It also has a built-in encoder, so it would do the encoding locally. All your keys would be stored locally, so you would have you can safely put in your posting key and your active key, and it's all operated locally. We might do some other stuff where we could like log in with already existing keychain or MetaMask, as MetaMask login will be fairly important to allowing you to log in with Ethereum, and do that, of course, locally, where you have that. You open up your web browser and then it logs into your local desktop app. We did do a pretty large refactor recently, so there's some issues in the app that we're still working out. So that's not quite there yet, and we've also had some other problems, like right now at the moment Hive SQL is down, which we rely heavily on, so the actual app feeds don't really work. But that's going to be worked out as we migrate over to the indexing system. And of course, I mentioned earlier that you'd be able to run a local ceramic daemon. Okay. So here's a screenshot of the desktop app. It's very familiar to the actual 3Speak website. This is a slightly older version of the app. There would be an encoder or an uploader button here where you can actually go to the upload. But on the actual app, you can go to that section and upload. That being said, of course, we have some issues that we're working out, so it's not. There's still some work there, but earlier versions will work perfectly fine, because we did do a big refactor, which has created a couple of problems for us. All right, so that's it.